Hey guys, Mr. Aguilar here. Hope you guys are doing good. It is about 2:30 in the morning right now. I'm finally making your video. I've been trying to grade all your tests. I just didn't have time this weekend to do it. As you can tell, I'm clean shaven. My wife made me shave up my beard, so it is what it is. She wanted me to look good for my daughter's birthday today, um, and for going to Disneyland. But she just wanted me to look good as much as I can be. Um, Want to do some stuff for you guys here. Create a video for you guys so we're not getting too far behind. Sixth period class, I apologize for not being there. Miss you guys. I hope you guys are all doing well. Um, but today's lesson is not that difficult. We're going to go and talk about systems of equations. You guys have been graphing. I've been showing you Desmos, so please still use that. It's a good program to use. Um, Hold on. Let's see. Ooh, too big. Let's change this up. Share Doseri. Um, my apologies. So now that we're here, let's go ahead and talk about our assignment. Looking at systems of equations, we have a different ways to show different solutions. As you guys can see, the three graphs that we have right here, we have one that intersects, two that are the same graph, that are parallel to each other, two lines that are parallel, and one that has only one solution. So we're looking at these. The key thing to note from a bunch of these is being able to identify the fact that if you have different slopes, a different slope solution means that you're going to have one set of solutions. So if you have an equation with different slopes, which we'll see in a minute, you'll have different sets of solutions. Let's go to reduce this. So the lines intersect. There will be one solution. Okay, we want to be able to see that. Basically, our solution for this one would be our one solution here, which will happen to be 1, comma 2. If we're looking at the next one, we can also have a variety of different sets where if we have the same slope but different y-intercept, we're going to get the fact that the lines are parallel. So then there are no solutions. If the lines are parallel, then we don't have any solutions. They'll never intersect. They'll never cross each other. So if they don't cross, we cannot say that they are the same. We cannot say we have any solutions that will match up with this. And I'll show you what I mean in a little bit. The one to the right, our final one here, shows the following. Last one, let's change this to green. The last one tells us it's the same slope, same intercept. We get two of the same lines right here. So the lines overlap. So the lines are, let's do same. So there are many solutions. It could also be infinite. Infinite solutions. So looking at these, we want to be able to identify what type of problem they're going to give us. Are we going to have one? Are we going to have many? Are we just going to have none? So we're going to identify that two ways. One by graphing. So if it can be graphed, that they're parallel. In this case, it will be our blue case, which is going to be no solutions. If they're going to intersect somewhere, we're going to have one solution. And if it gives us the same line, we have infinite. And we're going to be able to identify how those are looking soon. Okay. So here we go. Sorry about that. Let's do this. So the first one right here, you guys have these boxes. So go ahead and pause the video and continue to write. We're going to look at this via graphing our equations and see what it gives us. For our one solution, let's see what we have. What we have here, our slopes are all different. So if the slopes are different, we're going to have one intersection point. So that's going to be key with us. Same, different slopes, one intersection, one solution. So let's graph the top one. We're going to go up 2, and then up 1 over 1, up 1 over 1, up 1 over 1. This will give me a line that intersects to all of them. We're going to draw that right. Boom. The next one itself, we're going to go up 1, and then up 2 over 2, up 2 over 2. And this will give us an equation that goes to this one, which happens to be our intersection point here, which happens to be 1, 3. So this one has a one solution set as it described at our top. So we're going to look at one solution. Let's look at the next one. Our conditions are a little bit different for this one. We have the same solution, or we have the same graph, almost the same graph, sorry. We have the same slope. So because we have the same slope, we're going to be able to identify something about it. It's either going to be infinite or none. In this case, it's no solution. Let's graph it. We're going to go up 2, and then up 3 over 1. And then to graph this as well, back 3 down 1, back 3 down 1 will give us that same kind of slope. Let's graph that. It is important that you guys are graphing these fairly accurate, or else it will kind of look weird and funky. So just try to graph it as best as you can. Rulers are up in the front of the class if you guys ever need them. You guys know where to find them as well. We'll do the other one blue so you guys can see it. So we'll do top one. Let's do the bottom one. So down 2 right here, and then up 3 over 1, up 3 over 1. And if we graph this correctly, we know that both lines are going to be parallel to each other. So therefore, we don't have an intersection point for them. They're never going to intersect. They're never going to cross. So we know that we have no solutions with this. So that's one of the ways we look at it. Our last and final case would be that we have infinite solutions, meaning they're the same graph. And if you look at both equations, we're essentially graphing the same thing. It's giving us the same setup, the same look. So we identify it as the same line. Our slopes are the same, the y-intercept's the same. So if we just graph one of them, we're going to go up 3 for our b. So in this case, our b is equal to 3. And then our slope is going to be negative 3 over 4 for both cases. So I'm going to go down 3 over 4, which gives me that point here. And our line between them, again, will be the same graph through it all. Okay, so in this case, we have one straight line. It's the same graph both times, so it would be infinite solutions. So keep that in mind as you're doing this. We're looking for how many solutions we have for these sets. And if it doesn't give you a graph, I just want you, can you identify what it's providing you? And let's look at the next one. Let's look at the next one. So these ones are slightly different, as you guys can tell. Control this back in. Messing up on me right now. Here we go. Come on, man. There it is. As it's still kind of loading up, I still want to talk to you guys. Last day to turn in all material is Cinco de Mayo, which is this coming up Friday. Please be aware of that. We'll be going over the test on Tuesday and look for it to be updated. I think it is at this moment. I have all the grades in, so check that. If it's not, please email me if you don't see a grade up there. I think I just had a part of fifth period. I'm sorry, fifth period. And we'll get them in for you. Let's continue. Looking at these next sets, you can either graph them. I'm going to do it a little bit differently. I'm going to do both graphing and just identifying the slope and intercept and seeing how we're going to queue with those. Our first pair right here tells me that the first thing you want to look at this is our slopes. Because each of the slopes are different, are not the same, we're going to have one solution. And just because that is, I know I'm going to only have one solution with this and the way that they intersect. It doesn't matter about the y-intercept, which is our b. In this case, 1 is equal to 1. We only care that it is our slopes. If the slopes are different, we can identify it as one solution. So up 1 would be here, and then up 2 over 1 would be our next points. So there it is. The next one we're going to look at is the next one. So we have, a little bit thicker for you guys. The next one that we have is here. We're going to go up 1 right there, and then down 1 over 3, down 1 over 3, which will give me this line here. We have one intersection point. It happens to be this right here, which is 0, 1. So this is our one solution. It has one solution to this. For the next part of this, let's look at the next one. Our slopes are the same. So this puts it in the category of none or infinitely many. So our slopes are the same for these. In this case, they're both 2. The fact that we have different y-intercepts on this one, if they're the same slopes, different y-intercepts, that means we have them, so in this case, b1 is not equal to b2. We have no solution, meaning that these are going to be parallel lines to each other. Going up 1 and graphing these, we're going to go up 1, graph that point, and then up 2 over 1, up 2 over 1. If we follow the same slope going backwards and connect the lines, we have our first graph there. If we do the same thing with the other one, which is the one down below, we're going to go down 7. So 1, 2, 3, it's going to kind of be off the paper. It's okay. Up 2 over 1, up 2 over 1. And keep this idea going. And if we were to graph all of them at the same time, these lines don't intersect. So we have no solution to this set. They're never going to intersect. We can't plug in any values that would equal those x and y's. So we get that. Our last case here, which happens to be our many solutions, or infinitely many. And the reason case I'm going to look at is our slopes. In this case, our slopes again are equal. So m1 is equal to m2. And in this case, our y-intercepts are equal to each other. So we're essentially graphing the same graph. This system shares the same solution. So we're going to go up 1 to graph our graph, up 2 over 1, up 2 over 1, and we essentially get our final one here. They're not going to always be as clear as they're giving us here. I can give you systems of equation, or I can give you standard form. I can give you Hoy-Bucks type of problems, and you guys decipher what those are going to give you. But essentially, if we're given the same one, we're given infinitely many. This is many solutions, and we'll just write many. And that's how I want you guys to classify these things today. So let's look at a couple more problems, and then we're done with today. And you guys can finish up your homework. So here we go. I'll do a couple problems. So these are still on your sheet, so look for them. I believe this is on the back side of the problems. This is number 4. And then we have the one after this as well. So keep that in mind. Again, I'm going to do it both ways. You can do it by graphing. So still pull up that Desmos app and help you guys out graphing these if you guys need it. You will not be able to use this on the test or on the quiz. I do want you to be able to graph it because you will be having to do that next year. Looking at this first one, I want to identify the slopes. So our slopes are the same. In this case, both slopes are the same. But if we look at the y-intercept, because the y-intercepts are not the same, this is no solution. Let's see if I'm right. Same slope, different y-intercept, no solution. In this case, we're going to go down 3. So down 3 would give me my first one here. And then I'm going to go down 7 over 3. In this case, I can also go up 7, back 3. So I'm going to go up 7, 1, 2, 3, 4, 5, 6, 7, back 3. And these two are going to be connected right here. The next one we see here as well. So one on the bottom, which is our y-intercept one here. And then go, in this case, I'm going to go down 7 over 3, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3. which happens to be right here. It's a little bit off. So no intersection points tells me that there is no solution to it. So these are as simple as you kind of want to show them. Let's look at the other two. I think I did 2 problems for the other one. The other ones, we just want to identify it. Again, you can graph these up to tell me, or you can just work them out. So let's look at the next bit. Let's kind of put this into perspective. Um, so looks slightly different problems, as you guys can see. We're given a systems of equations that are both in standard and our slope intercept. The bottom one I'm not going to change because it is already in the slope intercept form. So I can look at the slope, I can look at the intercept to identify. So the first thing that we're going to do is we're just going to change the top one into slope intercept so I can match it with the bottom one. And let's kind of pull this down. We're going to do 3x plus 4y is equal to 5. I'm going to subtract out 3x to get 4y is equal to negative 3x plus 5. Again, I'm just subtracting 3x. Then dividing everything by 4. Divide everything by 4. And let's see what we get. We get our y's, our 4 is going to cancel out. Y is equal to negative 3 over 4. X plus 5 over 4. So this is my new equation that I want to look at and identify. So changing up my colors just so you guys can see it. We're going to look at our bottom equation. So this is what we did for the first one. And we're going to look at the bottom one as well. In this case, our slopes happen to be the same. So M1 is equal to M2, which is our slope 1 is equal to slope 2. But we also identify the last portion being different. So B1, which is our y-intercept, is different than the y-intercept down below. So they're not the same. So same slope, different intercept tells me we're going to have no solution. Okay. You can also graph these two out. You can graph both the standard form and graph form of these and find out what would be no solution. So check that out, see what you guys get for that one. Number 2, or the one right next to it, these are also on the back of these, so I'm trying to do some homework problems for you guys. Over here's what we're going to do for these ones. We're going to have our equation here. And again, we have it in y equals mx plus b. It's nice that way. There's not that much I need to change from that because I can identify it very quickly doing it. Let's go ahead and do the bottom one. So I'll do the bottom one in red for you guys just so you guys see the different contrast of it. I'm going to change it so it's in the y equals mx plus b. In this case, we just need to add 3x to both sides. Once I add 3x to both sides, it should everything work out. Our 3x's will cancel. Y is equal to 3x minus 2. So we have it in the y equals mx plus b form, and we identified that the first pair right here are the same. So our m1 is equal to our m2. And then we also have the second portion, which is our minus 2 and minus 2, which is our b's. b1 is equal to b2. Same slope, same intercept tells me that it is many solutions. Graphing these both, we're just graphing the same line, so it would be many solutions. So look at this stuff. These are very key, crucial stuff. You will have a quiz on Friday on these, so please check that out. And we'll go over the answer key with you guys tomorrow and just work on it one more day, probably using Chromebooks maybe, or Kahoot, or maybe just graphing them. So please check those out. Can't think of anything else, guys. If you have any questions, please email me. I look forward to seeing you guys. 6th period, I have a treat for you guys because I've been missing you guys. So you guys will hopefully see maybe on Monday or Tuesday. Tuesday, no, it's Monday. So take care, guys. Please do your work. Have a good day, guys. Bye.